Friday. It's up in YouTube a lot sooner. But yeah, so last week of us doing anything, I am adding that extra assignment today and tomorrow. Sometime this week, Ms. Gomez is going to be joining us. And then next week, Monday is our final day of review. And then we have our finals. That's it. And then that last week, which is technically only 2 days of Zoom days, we're just doing exit tickets. So you don't even have to come into class if you don't want to. That's only for days of, hey, I need help with this homework assignment or whatever. All right, let's get into our notebook. So again, we're on week 10 notebook. I already opened it up. It's right here. We're gonna work through all of these. All the pieces are down here at the bottom. That Tuesday, someone asked, is that Tuesday is the last day? 2 weeks from now. The last day of school is Thursday, the 3rd. So the last week of school, the last day of school is the 3rd. So that's and then the last day for us to like I expect you guys in class would be Thursday. Unless you guys finish your final on Tuesday. And then after that, there are exit tickets after that. Okay. Let me see here. All right. So again, we're going to work through this. If you guys want to follow along with me with the notes, you guys can click on the notes and see it there. I am going to start my presentation and we'll be going back and forth between both. And for some reason, my subtitles have stopped working, which is weird, but whatever. All right, give me a thumbs up if you guys are ready to get started. Clap if you guys need more time. Again, one more time, I'm going to put the link to the notebook in chat. Today is the only day that we're going to do notes. After today, it's just going to be practice and then our final review on Friday. All right, so what are you going to be able to do by the end of today? I can solve a system of equations by substitution. So remember, there's technically 3 ways of solving systems. One is by graphing, which is what we did last week. One is by substitution, which is what we're going to do today. Then the third one is called elimination, but we're not going to do that one just because we don't have the time. So we're just going to focus on those 2 first. So we're going to focus on graphing, which is what we did last week, and substitution, which is what we're going to do today. Hey, Ben. Oh, there goes Adrian. I am putting into chat the link to the notebook that we're just about to start. And then again, guys, sorry for, everyone coming in and out. If you guys want, this is being recorded, so this will be available to you guys at the very beginning of next period. So if you're getting frustrated of, oh my God, I hate this internet, you guys can just wait for the video and then just watch it on your own. So it's up to you guys. All right. So how do we solve system of equation by substitution? Well, it kind of goes with what the name says. Substitution is used to solve systems of equation by isolating. Isolating means to get it by itself, a variable in one equation and plugging it into the other equation. So I'm going to come here to our notebook and I'm going to find the I can statement and I'm going to pull that up. And then substitution just means that we're going to solve for one of the variables and then plug it into the other equation. So give me a thumbs up when you have both of those set. Okay. All right. We're going to solve one of these going all the way down. And the pieces, and I'll slowly be moving the pieces over here. So as we do one piece over here, I'll switch it into the notebook. So solve the system of equation by using substitution. All right, what does all that mean? So hold on. So what I'm going to do is I'm going to look at both of these equations. So this equation and this equation. I'm going to see which one of these is already solved. So I have y equals for this one. So this one's solved. This one and this one have the x with a number in front. So I don't want this one. I'm going to pick this equation right here. Hey, Chanel. We're doing our notebook. We just started. So it's in chat. This video is also, the class is also being recorded. So as soon as this is done, I'll post it to YouTube and you can watch whatever you might have missed, but you didn't miss anything. Not really, just the announcements. So I'm going to see this one. This one's already equal to y. So what I'm going to do is I'm going to take this 3x minus 5, and I'm going to plug it into y. How is that going to look like? It's going to look like this. So the 4x stays the same. I bring down the negative. I bring down the 3, and in parentheses, I'm going to put in this equation. I put this equation in because this is the one that's solved. And then from here, we're going to solve it. So my 4x comes down. I have negative 3x times negative 3x times 3x gives me a 9x. So I think I'm going to actually just draw these guys. Actually, to make life easier, yeah, I don't think I'm going to actually draw on there. I think I'm going to just do it here. And then what you guys can do is you can pull these up once I do it. The reason why I want to do that, guys, is I want to show you guys each and every step. And the way that this is done, it's already like pre-done, and I want you guys to see each and every change. So again, I'm going to take this 3x minus 5, and I'm going to plug it in to my y. So I'm going to get 4x minus 3, and instead of y, I'm going to put this part up here. So I'm going to have 3x minus 5. And then everything else comes down. From here, distribute. The 4x, nothing's happening to that guy. Even when it comes to this side over here, nothing's happening to this guy, the negative 35. So what is changing? I'm going to multiply negative 3 times 3x gives me a negative 9x. And a negative 3 times a negative 5, negative times a negative gives me a positive. 3 and 5 gives me 15. So we're just distributing. From here, this side has 3 terms, 1, 2, 3. So I'm going to combine my like terms. My like terms are the 2 that have an x or 2 that didn't have an x. That right there, 4 minus 9. So I'm going to take the 9, subtract 4, and it's going to be a negative because the 9 is bigger. And it's going to be 5x. Everything else comes down. So the plus 15 comes down. and then negative 35 comes down. From here, this is a two-step equation, and you guys feel fairly confident with two-step equations. So I need to move this 15 over to the other side. So I'm going to subtract 15 from both sides. And I get negative, oops, I want to do that in a different color. I get negative 5x. My 15s go away. Equals a negative and a negative. I'm still going to have a negative. This says I owe you $35. This says I owe you $15. So how much do I owe you now? Well, 5 plus 5 is 10. Carry the 1. 3, 4, 5. So I owe you $50. Someone asked, how did I get 5x from this highlighted part? I had 4x minus 9x. They both have x's, so I have to combine them. And I have $4, but I want to spend 9. So how much more do I need? I need $5. Does that make sense? Okay. From here, I need to get the negative 5 by itself. So I'm going to divide both of these by that negative 5. And I get x equals, again, negative and negative. This time it's going to be a positive because this is multiplication. And 5 goes into 50 10 times. Which, if you guys look, it's right here. So if you guys wanted to just move this piece over, you guys could. But I'll put it side to side. We're not done yet though, because we are trying to figure out this equation. We're gonna grab this 10. And I'm gonna use this in different colors. I'll do, let's do blue and pink. I'm gonna grab this 10 and I'm gonna go wee, and I'm gonna plug it back into my x. That way I can solve for y, because that's the whole point. We want to see, are we going to have one solution, no solution, or infinitely many? Since we were able to solve this and we got x equals 10, we know we're going to have a one solution. If we go back to last week's notebook, and I'm just going to open it up. Remember that second page, we talked about this piece right here. So this piece right here is for systems. So once I have x equals a number, and that lets me know I'm going to have one solution. If I got it so that it had like a number and another number, but they weren't equal to each other, then it would be no solution. And if I got the same number on both sides, then that would be infinitely many solutions. So we're looking for these three, or one of those three. So this lets me know I have x equals 10, which means I'm going to have one solution. So let's plug that into that equation. So I get y equals 3. Again, we're going to replace that x with that 10. And then minus 5. So y equals 3 times 10 gives me 30 minus 5. And 30 minus 5 is 25. Again, if you wanted to move your pieces, it would be this one. How many solutions is that? That's one solution. And then my solution is 10, 25. Remember, this is an X and this is your Y. So make sure that you guys put them in the right order. So far, for those of you guys doing your homework, you've been doing a good job of putting them in the right spot. I've only had to tell a couple of people that they put them in the wrong spot. So what I'm going to do is I'm going to erase this and I'm going to make it look a little bit nicer. I'm going to move those pieces into the correct spot, which is what I'm going to do with the others as we go along with everything. So I'm going to move these pieces. And I'll just draw what I did before. So we distributed. We combined. And we took this 10 and we went and we plugged it into the X. All right, give me a thumbs up if you guys are good. Clap if you guys need more time. Now, on your test and for your homework assignments, do you technically need to use substitution? No, you don't. You guys could always choose to graph instead. You could have solved this bottom one to look like y equals mx plus b. It's just up to you if you guys wanted to do it that way. Hey, Evelyn, we are doing our notebook. I just finished a piece of it, but you'll be seeing it here. I'll let you take a screenshot, but the class is being recorded so that you guys will get access to this very quickly. All right, let's look at this one. Now this one is interesting. Both of these have y equals. So it doesn't matter which one you're going to put into the other. I'm just going to grab this piece right here and I'm going to plug it into this y. All that means is I'm setting them both equal to each other. So again, it doesn't matter. It's going to be the same either way. So I'm going to have 5x plus 2. And again, you don't have to draw it like this. The pieces are down here at the bottom. And then I'm going to set that equal to 5x minus 3. I have an x on both sides. So what I want to do is I want to subtract them. So I can get the x's by itself. Well, actually, I have a 5x here and I have a 5x here. So when I subtract 5x, what happens? So this is one of my weird ones. 5x on this side goes away. 5x on this side goes away. By the way, I need to do that on this side too. So when I do that, I'm left with a 2 equals negative 3. So let me know. Thumbs up. Is that true? Clap if that's not true. Does 2 equal negative 3? Thumbs up if it's true. Clap if it's not true. Well, yeah, that doesn't make sense. 2 doesn't equal negative 3. So this would be a case of no solution. Again, if I'm looking here, it's going to be a number that doesn't equal another number. So that would be a great example for no solution. So what I'm going to do is I'm going to zoom out. I'm going to find that example. And then what's my solution? It's no solution. So all you have to do is just move this piece. And again, just so that I can make it look a little bit nicer, I'm going to get rid of all of this. All right, let's do that last one. So I'm going to zoom in on that one. Again, I'm going to look at the two equations that I have and see, is one of them already solved for me? Yeah, this one right here. This one's already solved. It says y equals. Does it always have to be y equals? No, it could have been x equals and we could have plugged it into the x. This one saying y equals, so I'm going to take this 3x plus 1, and I'm going to go wee, and I'm going to plug it into this y. Again, make sure that you're plugging it into the correct variable. Sometimes you might accidentally put it into the wrong one. So I'm going to get 4 parentheses. Instead of that y, I'm going to put in 3x plus 1 equals 12x plus 4. We're going to distribute. So 4 times 3x, 4 times 3x gives me a 12x. 4 times 1 gives me 4. Everything else is just going to come down. So notice how I keep changing my colors, guys. That's to let me know what is changing and what is staying. Do you have to do that? No, it just makes life easier, or you can just move the pieces up. All right, let's look at our x's, because I always like to get rid of our x's first, or, move those first, because sometimes they go away. So let's see. I have a 12x and a 12x, so that is going to make it go away. So I'm going to subtract 12x from both sides. Does it always go away? No, not necessarily. If you remember back from the beginning of the school year, it didn't always go away. My 12x's go away, my 12x's go away, and I'm left with 4 equals 4. Now, is that true? Give me a thumbs up. Yes, that's true. Clap if that is not true. Does 4 equal 4? Is that a true statement or is that a false statement? Yeah, that one's true. So again, zoom out for a little bit and let's move our piece. So I'm going to erase all my work. Move this piece up. I will correct the things that I had changed. Distribute, cross out, and cross out. Again, they do this piece right here. I don't really like this piece. So I'm just gonna cross these out. I just like to leave it as 4 equals 4 and then that's it. So again, I would probably cross that piece out. I don't even know why I left it there. And again, this piece should say 4 equals 4. I need to fix that. No. But if you guys can do that change, I'd appreciate it. And that's all your pieces. So let me zoom out. All right, give me a thumbs up if you are good with that. Clap if you guys need more time. So again, what are you doing? You're taking one equation and you're plugging it into the other. If you get x equals, you know you're going to have one solution. If you solve it and your x's go away, pay attention to the numbers that are left. Are they going to be different? Then that means it's a no solution. Are they the same? Then it's infinitely many solutions. So you're looking for those three things. You're looking for which ones are going to give you an x or a y so that you can have one solution. Two numbers that don't equal each other give you no solutions, or infinitely many for this one. Hey, Dolly, we're working on our notebook. We just finished the first page, so if you can take a screenshot of this, you can finish it up in a little bit. And this is also being recorded, so you'll be able to see it as soon as second period probably gets started. So give me a thumbs up, guys, once you guys are done with this page so that we can move on to the last page. There's only 2 pages in our notebook. Awesome, awesome. All right, so let's switch over to page 2. All your things are down here. So all you have to do is just move the piece. For this one, I am going to switch over here because it's done a little bit better. So I have y equals 4x as one equation, and I have x plus y equals 10. So that's what you guys have right here. So looking at both of these, which one would you guys start off with or plug in? Would you plug in 1 or would you plug in 2? So thumbs up if it's 1, clap if it's 2. So again, which one of these is easiest or already solved? Is it 1 or is it 2? So thumbs up if it's 1, clap if it's 2. Thank you. Thank you. Get to class. Oh, good, get to class. All right. Sorry about that. All right. So yeah, number 1 is already done. Ah, shift. Okay. So I'm going to take this y equals 4x, and I'm going to take this 4x, and I'm going to go wee, and I'm going to plug it into that y. So instead, the x stays the same. Instead of this y, I'm going to type in, no, because it's, you turned it off. Tobias, go away. Sorry, guys. So I'm going to take this 4x, and I'm going to plug it into y equals 10. From here, I can combine my like terms. So both of these have x's, so I can add them. I'm going to put this invisible 1. So 1x plus 4x, 1 plus 4 gives me 5. Bring down my 10 because nothing happened to that one. I got to get rid of this 5 in front to get the x by itself. So I'm going to divide both of these by 5. My 5's go away, and I get x equals 2. Since we see this piece and our x's, like our variables didn't go away, we know that we're going to have one solution. So what we're going to do is we're going to take this 2 and we're going to go wee, and you have to do the wee part. Like it is mandatory. Like I need to hear from my house, like you guys going wee. And you're going to plug that into the x over on this side. So y equals 4, take that 2, plug it into the x. 4 times 2 gives me an 8. So what's my solution going to be? This one is your x. This goes first because it's x, not because you solved it first, but because it's x. So remember, x goes first, and then your y. So if I come over here, I'm going to grab this. Is it this one? Yeah, it was this one. Yeah. So again, a couple of things that you might want to do. You might want to highlight these pieces to remind yourself. For some reason, my lines here disappeared, so I probably want to do that. And that's about it. Notice the way that I separated these. I kind of like solving them like this, because then I know that one thing is going to be solved on this side and one thing's going to be solved on this side, instead of doing it like this, where we're doing all of it going down and then even more down. Like, I don't like doing it like this, like in a straight line going down. I like doing them side by side like this. Yeah. So I don't know. I like solving it like that. Me remembering like, wee, that lets, again, it's one of those dumb things that reminds me, oh yeah, like it's supposed to like travel. It's supposed to go somewhere. Same thing with this x. Once you solve it, you're normally so used to just solving for x and then that's it, that you might stop there. And instead, you need to remember you should have two travels. You should travel once and then you should travel back to where you started. All right. So I would, if that helps you, awesome. All right. All right. So give me a thumbs up. A little bit down. Um, if you are done with that, give me a thumbs up. Clap if you guys need more time. Awesome, awesome. All right. So we're gonna go off to the next one. And notice I did help you guys out with, well, what happens if I do have an X as an answer? Wait, how did you get 5? How did I get 5? Oh, here, there is an invisible 1 here. So 1 plus 4 gives you 5x. Divide both by 5 to get rid of that 5. And then I get x equals 2. Are we good? Okay. All right. So let's go on to the next question. And if you guys wanted to, you could check your answers. You could plug in this 2 into this and see if you guys get the same answer. Or you can plug in the 8 and, check it. Or check it here. 2 plus 8, does that give you 10? Yeah. 4 times 2, does that give you 8? Yeah. If I divide both sides by 4, does that give me 2? Yeah. So you can always plug them in to double check and see if your answers are correct. All right, again, look at both of these two equations. Give me a thumbs up if you think it's going to be question number 1, or a clap if you guys think it's going to be 2. Which one is already solved for you guys? Is it 1, thumbs up? If it's 2, clap. Which one is already solved for you guys? So thumbs up if it's 1, clap if it's 2. Which one is easiest? So I kind of already gave you guys this one. I said that I was going to give you guys one that has an X. So you guys might be like, I don't know which one because I've never done one with an X. And that's okay. What we're going to do is we're going to take that X equals 3y, and I'm going to separate it from the other equation. I'm going to take this 3y, and I'm going to be plugging it in, but I'm going to be plugging it into this x, not the y, because this one says x equals, not y equals. So when I solve this, the 2 stays the same. Instead of the x, I'm going to plug in 3y. Everything else, the negative y comes down, and then equals 10 comes down. So again, this one's only different because it says x equals versus y equals, but it's still solved the exact same way. I'm going to distribute, multiply 2 times 3. 2 times 3 gives me a 6. Remember, there's an invisible 1 here the entire time. Bring everything else down. And if you want to add those ones to yours, that's totally fine if that helps you guys remember that you're going to be subtracting. 6y minus 1y, 6 minus 1 gives me 5y equals 10. We have to get rid of this 5, so we're going to divide both sides by 5. So I get y equals 2. So again, we took that, we plugged it in, we simplified it out. So all of this stuff here, you guys know how to solve this. It's just simplifying it out, plugging in the correct spot. That's the only thing that is new. Since I see y equals, we know we're going to have one solution because it says one of the variables equals this. And I'm going to take this y and I'm going to go wee, and I'm going to plug it into that y over there. So I'm going to have x equals the 3 times this 2. 3 times 2 gives me 6. Remember, x comes first. So this is first. Even though it will solve second, that's first. Any variable by itself is always going to have that invisible 1. Always. So if it's x, if it's y, even when I have like y equals mx plus b, this is 1y. Like each one of these like the variable by itself is 1. I hate this red. With this background, it sucks. That's better. So what's my solution going to be? It's going to be 6 because I said the x always goes first. Think of your alphabet, x, y. So x, then y. So when I come here to move those pieces, it's going to be the bottom one. So a couple of things we did. We went wee, and we plugged it into the x. Again, to help you guys out, I'm going to add those ones to my y's so that it makes it easier. And I'm going to take this 2 and I'm going to go wee, and I'm going to plug it in. And remember, S first. This is your X and this is your Y. All right, give me a thumbs up if you guys are good with that. Clap if you guys need more time. And remember, if you guys are confused on anything, someone's been asking a lot of, making sure that, they understand. If you guys need, something, please let me know so that you guys can understand everything. All right, let's look at this bottom one. So this is our last equation or our last problem, and then we'll look at our homework. So looking at the top and looking at the bottom, which one is already solved for you guys? Is it 1 or is it 2? So thumbs up if it's 1, clap if it's 2. Which one is already solved? Which one has x equals or y equals? So thumbs up if it's 1, clap if it's 2. So yeah, this one already starts with x equals. Is it always going to be the one on the top? No. I just made it so that it followed a pattern for you guys. But it doesn't necessarily mean that it's always going to be that one. So let's substitute them. I'm going to have that first equation. I'm going to move it to the second equation. The wind is worse than yesterday. Yeah. Actually, like, let me see. And it was like crazy bad. Actually, it was worse last night. Right now, the wind is 20 miles per hour. Last night, it was 27, 28. So it was pretty bad last night. But yeah, if you guys are getting like kicked off, that's probably why. For some reason, my lines are bad. It should not be here. It should be up here. And we should be plugging it there. So don't pay attention to that we line. And then my line's not going to go away. Okay, I'm going to have to fix these. Give me 1 second. Discard. Hold on 1 second. Um, Happy birthday, Zoe. Sorry, it's like someone's birthday in my son's room. Oh, that's not what I wanted. I wanted this to fade away. I think I messed that all up. Okay. Sorry about that, guys. All right, so we're going to take this and we're going to plug it into our X. That makes this guy come right next to where the X is. So 2 comes down. Instead of putting X, we're going to put in all of this equation. Then everything else comes down. The negative 5y equals 26. We're going to distribute 2 times negative 3y gives me a negative 6y. So 2 times negative 3y gives me a negative 6y. And then 2 times the negative 9, don't forget that negative, gives me a negative 18. Everything else comes down. Look on the left and see what you guys can combine. I can combine the negative 6y and the negative 5y. So I can either add them up or subtract them depending on their signs. Both of them are negative, so I owe you $6. I owe you another $5. So 6 plus 5. Someone said it was going to be a positive. Remember, I owe you. So if you make it positive, that means you owe me. So I owe you $6. I owe you another 5. That means I still owe you, but how much money do I owe you? I owe you 11. So it's still negative because we're talking about owing you guys money. So adding and subtracting negatives, always think about owing people money. When you're multiplying and dividing, that's a different story. But adding and subtracting, always think of owing people money. So if I have 2 negatives, that doesn't mean that all of a sudden, instead of me owing you, you would give me money. Stop letting me borrow money too. That's not good. And again, guys, that is one of those reasons why I say, use a calculator, because a lot of you guys are not good with adding and subtracting. You always confuse it with the rules for multiplying and dividing. And you're not the only one. A billion other, high schoolers and even adults do that all the time. All right, let's simplify this. This negative 18 is going to go away. So I need to get rid of it. So instead of subtracting 18, we're going to add 18 to both sides. The 11, negative 11y comes down. My 18s go away. Equals 26 plus 18. 26 plus 18 gives me a 44. And then I have to divide both of these by that 11 to get rid of the negative 11. So divide both by negative 11, and I get y equals, this is where you guys do the negative and positive. So a positive divided by a negative, we'll keep it as a negative. 11 goes into 44 4 times. Remember, we traveled once, which means once we're done with this one, we need to go back. So we're going to go, wee! We're going to go back and we're going to plug it into this y. So I get x equals negative 3. And instead of writing that y, we're going to write in a negative 4 minus 9. So lots of negatives. A negative 3 and a negative 4, a negative and a negative. This will make it positive. So x equals 3 times 4 is 12 minus 9. 12 minus 9 is 3. Remember, this is x. X goes first. Even though it was second, x goes first. So my solution is 3, negative 4. Remember, this is an x, and this is a y. So I'm going to move that piece here. So I'm going to go wee, and I'm going to plug it into x. I'm going to distribute. So I'm going to combine like terms. We're going to distribute those two as well. And there you go. Question for you guys. Which one do you feel, and this is a personal opinion, which one do you like more? Thumbs up if you like graphing more. Clap if you like substitution more. Or, yeah, thumbs up if you like graphing. Clap if you like substitution. And again, there's no right or wrong answer. Just wondering. So a little bit of both. Personally, I like substitution. Um, that just makes it easier for me. I don't like graphs, so I don't like graphing. So I like substitution. Um, but can you do either one? Yeah, totally. All right. So once you guys are, does anyone need this anymore? So thumbs up if you guys are good with your notes. If you guys are 100% done, you guys can turn it in. That's it for notes for like ever. Kind of. Tomorrow we'll have a little bit, but it's not going to be in our notebook. So it's going to be in an activity. So you guys can start turning those in. So you guys can turn that in here if you guys want. Let's open up our homework for today. So let me put that into chat. Let's click on that. So what I put into chat, can you go back real quick? Yes. There you go. All right. Sorry, I'm listening into my son's class and they asked like what was your favorite day of the school year? And my son's like every single second. I'm like, really? Really? It's not. All right. So your homework assignment is this. You guys are going to have 2 pages. One page you're going to practice graphing. One page you're going to practice substitution. So on this page and on the next page, I want you guys to pay attention on, is it one solution, no solution, infinitely many? Is it going to be like our notes are and you're going to have one of each? No, you might have them all be one solution. You might have all of them be no solution. You might have a combination of them. So it depends on, what you guys get. Um, but what you guys are going to do is you're going to solve each one of these, and I will do the one of these from the bottom. So you guys can either tell me in chat if you want me to solve either 3 or 4, because that one you have to actually solve for one of them, which is what we did last week on Friday. Remember how we had to solve them and put them as y equals mx plus b? So we're going to have to solve both of these in order to do that. And you have plenty of space to do it here. So you can show me that work. Once you guys have the answer, if it's no solution, circle. If it's infinitely many, circle. If it's one solution, you're going to circle that, but then you have to tell me what the points are. So like 3, 4. So make sure you guys follow those directions. Which one do you guys want me to solve? Either 3 or 4? Put it into chat. Which one do you want us to solve? 3 or 4? Whoever puts it in first, I'll do that one. 3. Okay. So, oh, I got 2 3s. All right. So let's do 3. So I'm going to write a 3 here. I'm going to type them out. So 2x plus y equals -1. Well, this one's actually nice because the y is already by itself. So this one will be fairly easy. All I'm going to have to do is move that -2x over. So instead of subtracting 2x, I'm going to add 2x to both sides. So I'm going to get y equals, remember the 2x goes first, I can't combine them, 2x minus 1. So my slope is going to be 2 over 1. So I'm going to go up 2 and to the right 1. And my y-intercept, my b, is -1. So that's where I'm going to start first. So let me zoom in a little bit more to help me out. I have it -1. And then the other one is up 2 over 1. 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 Or I can go down 2 over 1. Down 2 over 1. And then connect our dots. So that's our first one. We do the work for them on a separate piece of paper. Yeah, for 3 and 4, you're going to have to use separate sheet of paper. You can either do it down here on the bottom like I am, or you can do it on a separate sheet. Let me zoom out so that I can write this next equation. Zoom out a lot. Um, I got 4x plus 2y equals -2. All right. This one, however, is not as nice as it is with the other one because I have 2y right here. So it's going to take me a couple of more steps. I still need to get rid of that x. So I'm going to do the opposite. This is a -4x. So I'm going to add 4x to both sides. Add 4x. So my 4x's go away. I'm left with 2y equals, again, I can't combine those. I'm going to leave them side by side. 4x minus 2. Again, you don't have to do this on ClassKick. You guys can do it on paper, but then I need to see that paper or else I will dock you guys points. I will dock you guys 2 points for not doing that. So divide everything by 2. Why? Because I have that 2 right here in the front. So I'm left with y equals 2 goes into 4 2 times. Oops. Minus 2 goes into 2 1 time. So what's my slope? 2/1. Can anyone tell me what they think, how many solutions this is going to give me? Can someone put it in chat? You should be able to already tell me at this point. Remember, looking here, we can tell if our slopes are different, it's going to give me one solution. If my slopes are the same, but my y-intercepts are different, it's going to be no solution. And if they're both exactly the same, then it's going to be infinitely many solution. The audio is cutting out. Can you guys hear me? Give me a thumbs up if you guys are hearing me. Yeah? Okay. Maybe it's internet connection that's making it bad. Again, with 20-mile-an-hour like winds, it's bound to make things bad. But it should be recording just fine. So if you guys have any issues, again, this will be put up, fairly quickly. So looking at this without even having to graph it, I can already tell how many solutions I'm going to have. I look at my slope are the same. If I look at my y-intercept is the same. So looking at last week's notebook, if I have the same slope and the same y-intercept, that means everything's the same, which means I'm going to have infinitely many solutions because they're both on top of each other. So we're only going to see one line here because both of them would be on top of each other. So again, I would have another line. Where's my line? On top of this one. So we should see 2 of them on top of each other. Okay? On the other one, the only thing I'm going to help you guys out with is I'm going to grab this guy and I'm going to show you guys where you're plugging them in. So that should go into your Y. This guy right here should also go into your Y. And this guy right here should also go into your Y. So they're all pre-solved for you guys. All you're doing is just plugging them in. solving it, again, you guys can do it down here at the bottom inside these boxes, and then tell me, is it one solution, no solution, or infinitely many? Don't forget to write that at reflection. And I want to say your exit ticket is already up. Yeah. So if you guys refresh that, you guys will see your exit ticket. And that's it, guys. If you guys need to see a page again, let me know. Try and get this one done as quickly as you can. Page 1 and scroll down. Yes. There you go. Tomorrow, we're going to practice even more on substitution with a little bit of graphing. I haven't put up the homework for tomorrow. I totally forgot. So I will put that up today here in a little bit. But other than that, guys, you guys are free to go. No problem. And I will see you guys